get the estimated values? How can you get the real values?
Can you repeat the question also?
If you generate the actual execution plan on the later versions of, on the later versions of SQL Server, it will say that it's still the estimated row count and estimated plan cost. In the earlier version, it said actual when in fact it was, or didn't say the estimate, but in fact it is the estimate based on the estimated row count. The way you get the actual is by reading my document on the full set of formulas for each of the operations and calculating it yourself.
Then that last question for this, can you get to the standard event actual values for execution? Real CPU time, real I/O cost?
Yes. Can you get the real values for CPU, I/O, and so forth? Yes. You can get it down to every single I/O that was fired for the system.
But not plan cost.
No, not for the plan, but this was specific for the execution.
For the execution, so you can find the crossover that you talked about.
The crossover in the true CPU and duration. But, right, the only plan cost you can get is for the estimated rows.
But in extended event versus, if you set an extended event session up for a single execution, as I said, you could basically get a line for every single I/O call that was sent and the time, the duration it took for doing that specific I/O.
That was the answer I expected.
Good. Yes.
When you're setting up extended events, is there any target which, I mean, depending upon the target you choose, is there a case where you should use only asynchronous targets and not, I mean, what I'm trying to say is, like, if I have a production server and I set up an extended event, would in any situation it might cause a little bit slowdown? Because when we had database snapshots, my servers failed because in 2003, Windows 2003, it hit a 64 GB size limit back then.
Yes. Well, the question was basically, is there any overhead in turning this X event on? And if I throw, how many events can I put in a trace without seeing any overhead? Basically, that was the question. And yes, of course, there is an overhead. If you say, I want to see everything right now for the whole instance, your instance will still die because you will be dwelled in millions of events. But there are many flavors to extended events which I haven't even talked about. One thing that you set up when you create your session is how many events am I willing to lose? And they have made it that way to protect the system. So in the base setup, if we don't do anything, we basically say we are willing to lose one event. But you can actually set it up to say, I'm willing to lose multiple events. And they have made it that way to protect the system, for not make it a possibility for you to kill this system by doing event tracing. But on the other hand, I must say, and this, I mean, it was 1 hour show. I have a whole day presentation. But when you go in and look at the different events, each and every event is matched to a category, right? And that category basically describes how many events you can expect it to fire. So if it's a very high level event, you can safely put it in there. But the more low level it gets, like locking, you can expect it to, evolve a lot. So there's a different, you still need to know what you're doing, but you don't have to be afraid. That's my basic. It won't kill your system just you doing a regular event tracing. You probably won't even see it running. And also, I didn't mention it, and I mean, that's one of the key points also, just finishing here, is that the reason that they created extended event versus the old eventing system it was because the old eventing system was so slow and ineffective. So this whole code, this whole new piece of code has been minutiously tuned to create as little overhead as possible. I believe they had a measure saying each and every event file has approximately cost of 2 microseconds per event as a cost. So.
I think the question was also about different kind of targets, synchronous targets and asynchronous targets.
Yeah.
Yes.
Is there a target you need to be very careful with?
No, I would not say that the target is the most important thing. I would say still that you have to match, you have to look at what the event, what level it's at, and also are you willing to lose a couple events in the safeness of your instance. That's more important than choosing should you go for the buffer target or the asynchronous targets or the synchronous targets.
The number of events to lose, is that a value in the event session config?
Yes.
But I believe you said your thing ended at 64 gigabytes. You might want to try to figure out how to find your problem without less than 64, because I think you're probably collecting more than you need.
Well, no, that was a different situation.
Okay.
It was just like my reference was that a new technology was introduced and I used it, and there was an operating system limit on the, because that was database snapshot. So when the database snapshot size got to 64 GB on the Windows 2003 server, at that time, without any of those bug fixes and all, it actually stopped writing and my database was still.
But as I said, out of the box is saved in a way that it's all in a memory queue, and if that memory queue is filled up, it's going to begin to throw them out, right? And another thing is that with extended event, it's very well contained. So you are not allowed to use up the whole 64 gigabyte with extended event information. It's very, very well contained. So for example, if you use the ring buffer, which was the memory buffer, it has a 4 megabyte limit. And depending on how much memory you have on your system, you are allowed to create a maximum, I believe it's 100 sessions. So that will not happen. They have actually in the very, very first release, you were allowed to say, I don't want to accept any losses of events. I believe they have removed that one. So one single event loss, that's the mildest one. But I mean, you can live with that, because if that happens, they are at least honest enough to tell you that in the trace file. So you can live with that.
If you have an SSD disk, is there any way to tell the optimizer that so it will be tweaked for that, so that sequential and random I/O take the same time?
Okay. If you remember that early on in my slides, I mentioned Paul White from New Zealand, and he had some DBCC commands. I believe it adjusted the CPU to I/O ratio. It didn't adjust the random to sequential ratio. Potentially, you could look at what the CPU ratio is and what the I/O ratios. I told you what the I/O ratios were. I never bothered calculating out what the CPU ratios were. If it's different, you can adjust those two ratios, the CPU to I/O ratio, and change it. But usually I just force the execution plan if I know it goes where I don't want it to go. And a lot of times it's because it's switching to a table scan sooner than I wanted. Notice that we have a query hint force seek, which says use an index if it's there. But I didn't want use the index blindly. I just wanted to use the index more before you switch. But I didn't get exactly what I wanted. Anyone else?
Joe, when you presented the measurements for sequential I/O, have you seen whether they at all take into account the fact that you frequently or might have might not have sequential value. I'm talking about fragmentation in a heap, like forwarding pointers, or in a cluster, in a B tree, you have fragmentation.
The plan cost does not consider that. It just says if you're doing a key lookup or a loop join, the I/O costing is essentially 320 per second. So they're not saying, I called it random, they're not calling it random. They're just saying it's 320 per second. And if it's a sequential operation, I'm sorry, if it's a table scan, they're saying it's 1,350 pages per second, irrespective of the fragmentation of the file, the type of hardware you have, whether it's scrambled or not. That's what you get. And like another, you remember I said it's different if it's on disk and if it's in memory. Potentially you could use the the memory object thing to see how much of the table's in memory, but I guess they don't want to go there either. So the impression I get is there's a huge amount of reluctance, because it will whatever change you make, it will make someone's query run bad.
Yeah, I think this also relates to you want to have different measurements for SSD disk. Yeah. Connor, for instance, don't want to do that. They don't want to touch the numbers.
Ask Connor when he's going to retire, and when he says he's going to retire, say, okay, can you slip it in now? That's always a good time, right, to change something? I mean, it's not my problem anymore. But no, I think this is somewhere where you have to identify. So there's no magic button you can push to make SQL run perfectly. If there were, they probably wouldn't need someone of your skill level. So your value add is your knowledge of when to override. So it's good and bad, right? If SQL were a perfect product, I wouldn't have. I'd have to get a real job. I don't want to do that.
This for Raoul. There's a long duration for SQL statements. Is there a way to get the count of a statement that executes, not a long duration, but it executes many times, like thousands of times? You get that the total cost of that query instead of just getting a few queries with like 10 or 20 seconds duration. Do you understand?
Basically, and this is, I think this answers your question. I set the filter up. In this situation, I set it for higher than 1, for example. So you could, if you wanted to, say, I want everything. That's not a problem. I've done that too. If in this case, I was looking for the wait info. That's a very, very frequently occurring event, right? But SQL statement completed, as you know, from Profiler or RPC completed or whatever, that's not such a frequent event. So you could easily put that in a trace session and say, I want it completed, and I want everything, without being afraid that it would kill your system.
But you still have to do group by in the query.
Yeah, of course, but that's regular SQL on top of it, just like I did.
Yeah, so that, what I meant was the total count of that very fast query versus a few queries with a long duration. That's what I meant.
You could easily create a bucket where you could set up a diverse filter to say, in this category, count it in this bucket, and if it in this range, count it here. And then you could get a histogram on the ranges on the duration. So you could say, everything that's 0 up to 1, count it here. Everything that goes from 1 or 2 to whatever, here, and everything above that, here. And then you could get a histogram that easily could tell you in which duration ranges your queries are. Yes?
It's just a comment which I took a while for me to realize, and might want to make it clear to everybody perhaps, is that there's no real-time analysis anymore with Xevent.
No.
So you don't see the rows passing by and you always have to chew the XML.
True,
to work that
true,
effectively.
true, yes.
Well, in one case, if you use a ring buffer,
Yes, but still, it's still XML, and it's not right there. It's aggregated in the buffer, and once the buffer is released to be available to ring buffer, there can go a couple of seconds there as well. So it's not created to be a live monitor kind of tool out of the box. But I just want to give an example more, because I get the feeling that people might think that turning this on can be very, very bad. So, just give you an example on how lightweight it is. I've been working on this huge Nordic insurance company. We did a huge consolidation case. So we packed 1,500 of their databases in one single instance on a cluster, right? On top of this system, I created an invoice system based on extended events. So what you saw here was one event. We are collecting 5 events, 24/7 on this instance, with all these different applications hammering the system 24/7, right? And we can't even measure the impact of us having running this extended event session. So that kind of gives you a feeling on, don't be afraid, go ahead. Yes.
Yes, we have an old SQL 2005 server which we upgraded to 2008. Before we had problem with the max degree of parallelism. And do you think it's safe now to also try and turn it on and see what's happened, or is it a recommendation to still have it set to no parallelism?
What was the other? The default 0, you had a problem,
Yeah,
and with 1, it's good.
yeah. Because with
You never-
2005, and now we upgraded, we are not trying to change it.
And your system had more than 2 processor cores, right? So you never try the numbers in between. I suspect your problem is running, so the default is parallelized across all processor cores. That can be dangerous with the small queries. So, and also my view is the minimum plan where it considers was set long ago when the CPU cores were much less powerful. And because they're so powerful today, you don't want to consider a parallel plan. You want to save parallel plans for the bigger things. But the thing is, it could kick in for small things that occur in volume. So if you were to turn it on, I would increase the cost threshold of parallelism to a number bigger than 5. You could pick 20 or 50, and you might start with 2.
Okay.
But if you do maintenance at night, do like the index rebuilds with all, there you don't want to wait.
Okay. Do you have a feeling about hyper-threading here? General comments?
Okay, if you have the older generation Intel processor, which went out 3 or 4 years ago, if you had the very first generation of Intel processors that supported hyper-threading, and that was like 9 years ago, leave that off because it had a number of bugs. Then the one that followed a little bit later was a little bit better, but still had some issues. In the current generation, it's supposed to be good. The guys who do the TPC and TPC-H benchmarks tell me they get 30% gain on transactions. And when they mean transactions, they mean a lot of network round trips, but they only see 10% in the data warehouse. But someone else told me that they had a problem with their iSCSI drivers. Well, I had to try to hold back a laugh for using iSCSI with an intense I/O load. I'm not convinced it can handle it, but a lot of databases don't generate intense I/O, so there may be nothing. It may be okay to use iSCSI. Don't use iSCSI in a data warehouse. And apparently that particular iSCSI driver had problems with hyperthreading.
I believe also there's another possibility with Enterprise Edition. You can create resource groups in Resource Governor, saying that you can use parallel if you belong to this group and not if you're in this group.
I thought it was only maximum CPU. If you like to get into port affinity.
No. I believe you could actually set DOP in there. in
Is this like
2008.
release 2?
Except the workload group.
Yes, in the workload group, yeah, you can set it there, right?
Okay, no, I did
Yeah.
not know.
So you can create, if you know you have a reporting server,
Mhm.
you can say you belong to this group and you know that he will be allowed to run in parallel, but your ordinary users use one or whatever. Yeah.
I have a question about sort of query plans, how they're generated. I've seen in the live system at a customer that they have really big problems in production, and the same query was running fast in test, and eventually it turned out that when we increase the available or decrease the available memory in production, it runs as fast as it did in test. So do you have any experience with available memory impacting the sort of query plan generated?
I've seen that as well, yes. I've seen actually a system running excellent when it had 4 gigs of memory, and once we bumped it up to 32, it went bananas.
Okay, remember,
Any idea what
remember when I showed you the hash join details and the CPU was this much and the I/O was 0? If you look up the definition for a hash join, it says there's an in-memory hash join, a graceful degradation, and a recursive. What happens is once it gets beyond in-memory, the intermediate results of the hash join are big enough that it has to spool to temp dB. That set point is calculated based on the amount of system memory. So by setting it lower, setting maximum memory lower, in essence, you're saying spool out to temp dB sooner. It affects the costing of the hash join. So basically, you're increasing the cost of your hash join, but I'm not sure. What you want to look for is a difference in execution plans. It can change the it can definitely change the cost of the plan. I'm not convinced it will change there's a couple of possibilities that it could change the plan from a hash to a merge. A parallel merge is very bad. A regular merge is okay, but only runs on a single, so I would need let's see, what else could...
But what you are saying basically is that the less memory, the more nested loops you're probably going to see.
No. It changes the costing of the hash join. So, but the thing is, just because you change the cost of the hash join, it may not kick it out of a hash join. And if it was a hash, and we don't even know that, it'll probably go to merge with sort rather than, or it could have. I know certain memory settings. Memory settings can affect certain parts of the plan. I've just never seen it have a serious negative effect.
The events you're mentioning, are these the ones that show up as warnings in the profiler with portraits, for instance?
No, it gives you a warning whenever there's a hash. So apparently someone long ago thought hash was bad, and they made it a warning in profiler.
I thought that was when you sort of spilled over or anything.
I don't think it's the spillover. I couldn't be sure, but I think they just kick in. The thing says hash warning. So to me it says, well, it's a hash join, but I could have a little hash join and it doesn't hurt too much. But when your hash does spill to temp, you better make sure your temp is set up right.
Just to give you a reference what happened. I mean, this query took 2 minutes, I think, in test and about 1 hour in production. That was quite a big.
What about CPU?
It was more CPUs in production, and also hyper-threading was turned on. We turned that off, that we could run eventually with the sort of original big size memory in production. So that was 2 things going on there, with memory and hyper-threading.
And this was the older generation hyperthreading, not the Nehalem.
Well,
How many years ago? Was this more than a year ago?
This was like a year ago, I think.
Was it an old system or a brand new system?
I don't know. Let's see if we can see who was there with me. But, I don't remember the hardware.
Okay, so
right here.
a year ago is when the newest hyperthreading came out. Okay, so when I said about the memory calculations in the hash join, it's a memory calculation per thread. So if I double the number of cores, so if it does a memory calculation on how much it can keep the hash in memory, that's per thread. So if I double the number of threads, the combined memory before it spills into temp DB has just been doubled, including the logical. It doesn't consider the difference in the logical processor. So it's a very large shift in the planned cost. But I do believe parallel hash joins with hyperthreading is probably not good. So I think I'm more inclined to think it's that than the memory shifted you into a different plan.
In our case, it was actually that there hadn't been any for the maximum target of memory. There hadn't been any, pre-thought on how that was configured. So they had said, well, the operating system needs like 2 gigabytes, and we give the rest to SQL Server. And that was actually causing starvation for the worker threads, because you have to calculate that as well. Because, yes.
I'm sorry, yeah, the TPC benchmark people also told me that too.
Yes. So in our case, it was actually spilling to disk all the time. It was swapping all the time.
I mean, the worker threads is outside of the buffer pool.
Yes, exactly, because the max target is the buffer pool. And people bump that up and say, well, we need 2 gigabytes for operating system, and we give the rest to SQL Server because they misinterpret the max target and see it as the whole instance, and that's not the truth.
I believe in the benchmarks, they explicitly set SQL Server, max SQL Server memory to a certain percentage of system. It might be they might be leaving like 10% or 8%. I'd have to look up the number. And it was something where it was taking too much memory.
Yes.
So that's where dialing it down could have, and that's a more plausible explanation than the shift in the hash join.
There's a Microsoft guy, Slovak something.
SlovaOx.
Yes.
Okay.
He has written on his blog as well how you calculate it. So you basically go in and query the DMV and you find out what has been the maximum amount of worker threads, and then it's very, very simple. If it's 32 bits old, it's like a half a megabyte per worker thread, and from up to 64 bits, 2005 it's like 2 megabytes, and 2008 it's like 4 megabytes. And you multiply that by the maximum number, and then you know how much you also have to spare in memory to make certain that the whole instance, that plus a little more extra overhead.
There will be some changes in Denali. I read in a blog post about a week ago
Yes, could
when
very well be.
large pages will be included in max server memory.
Okay.
So watch out for that when you configure.
But I've seen that many times, especially on 64 systems, because people just read max memory as, that's the whole instance, but that's not the truth, that's the buffer.
Yes, I have a question just about the parameter max threshold of parallelism. Have you some recommendation?
Cost threshold for parallelism, yes.
Yes,
5, I believe, is too low because a planned cost of 5 might run in 20-30 milliseconds. That is way too low to be kicking in parallelism. I'm inclined to look at your query runtimes and pick the query. If you're running without parallelism, pick the queries that take 200 milliseconds or more to run. Take a look at the planned costs of that. And also, you should also make a decision on when you want parallelism to kick in. Is it for the 200 millisecond queries or the 5-second queries? So just, if you make that decision and your 5-second queries have a planned cost of 200 or 300, maybe consider a bigger number. I do know that it can benefit planned cost 20 or whatever, but it might be, even without parallelism, that planned cost 20 runs quick enough that you don't, there's no user perception. So you have to balance those two, but definitely bigger than 5. And definitely you don't want something with a planned cost of 20 kicking in all 16 32 CPUs. That will hurt you badly.
But each value is this one, 5, is 5 seconds, 5 milliseconds.
Planned cost of 5, which in a 1997 system represented an estimated runtime of 5 seconds. The system, 1997 was your Pentium Pro 200 megahertz. You now have about 20 times more compute power in a single core. That's why maybe you might want to think about 50 to 100. But the thing is, it varies depending on your strategy.
Yeah, you have to take into account that you should have enough I/O. You shouldn't have I/O contention if you use parallels. If you have I/O contention, the parallels will even increase the problem.
Or at least you don't gain anything because you just sit and wait for the I/O. So your data is in memory, parallelism is good. If you have a proper fast track type of architecture or an extremely powerful I/O, the more threads you throw at it, the more I/O it delivers. But if you're not in that range, if you have this weak I/O system and your query goes to disk, then yeah.
So basically what will happen then? So you have 16 cores, you have a slow disk system and a parallel plan. Basically you have all 16 cores sitting waiting for one core to fetch something from slow disk. Is that?
Well, no, all 16 cores are issuing neat I/O. I don't know how many threads it actually does I/O, so it waits for those threads.
But
So
in
you
worst case, you could have that happening and you will have...
You see all 16 cores with a tiny amount of CPU usage, and you may or may not be blocking other things that need to run.
But they can do other things. It's not that they're blocking other.
Right, I think
connections.
if the thread issues I/O, it can yield to someone else. But I've noticed unusual wait times when it's running at max degree of parallelism. So, but I don't think it's blocking on I/O, but you're definitely not gaining anything if your I/O system is saturated.
You can also get the cost of all your queries from the plan cache. So you can pull that out and you can see what is the average cost of my queries. And out of that, you can decide on which boundary fits your system.
On that matter, getting the plan costs from each plan one by one is kind of a pain. Go to my website, there's a tool called exec stats. I'll just grab the contents of the DM exec query stats, grab each plan, and you have in an Excel file the plan costs for all your plans.
Okay, I'm sorry to have to ask you to round up here because we have to finish now.
Be Danish.
Yeah. So thank you very much everyone for
Thank
coming.
you.
Thank you.